Correct? Working, right? Yes. All right, children. So, which question did we stop? Yeah? Ninth question complete. Ninth question complete, or the solution of ninth question is completed, or the discussion of the solution of ninth question is completed, or the solution of ninth question in KCET PYQs belonging to chapter 8 mechanical properties of solids is completed. Okay. So who will read the 10th question now?
A stretched wire of a material whose x modulus y is equal to 2 into 10 to the power 11 Nm minus 2 has Poisson's ratio 0.
Okay, but our ಕೆಲಸ ಮಾಡಿ Poisson's ratio is not there for you. Leave that. Go for the 11th question. Which question, Buddha? हाँ.
A thick metal wire base and length is hand 1 half from a rigid support. The increased in length of the wire its own weight y is equal to Young's modulus of the material of the wire. Option 1 PGL by y. Option 2 1 by 2 PGL square by
Row, Buddha.
by
Row.
rho GL square by y. Rho GL square into y. Option 4 1 by 2 by rho GL square.
Yes. So how to find out what is the right answer? He is telling us that we have to find out the change in length. Correct, Buddha? So let us do one thing. Let us say that the considered rod or any object that has been given is suspended from the ceiling. Let us say that I consider a certain position at a distance x from the point of the suspension. Let me say that we are taking a small thickness of dx to determine what is the actual, what you can call the change in length. Okay. Now we know that Young's modulus is given by y is equal to f L divided by A delta L. Correct? Any doubts in that? Now what is the F? See the question. The question says that it is self weight. Correct? What is the meaning of self weight? Anybody can let me know what is the meaning of self weight? Anybody? Okay, how many of you have seen the movie Ghazni of Amir Khan? Nobody? Nobody has seen the movie Ghazni of Amir Khan? Hey Bhagwan. Okay, anybody has seen, we can say, a person pushing up pull-ups? Sorry, not pushing up, pull-ups. So why that pull-up has been done? Yes, so that means that is what is called as self-weight. Are you understanding? That means because of the weight, what will happen? Our hands will stretch to maximum. Are you getting what I'm saying, children? So that is what is called as self weight. It is one of the exercises that will be given in, we can say, gym, if you have to increase your height. Are you getting that? So now this particular force will not be the force, it will be the weight. Now what is the meaning of weight, children? It is the product of mass and acceleration due to gravity into, of course, L divided by A delta L. So this is nothing but we can say Y. Okay. Now what is this M, children? Remember, we don't know the mass here. So what we can say is that we can go for mass in terms of a known quantity of this particular substance, that is the density. Okay. So then we can say that Y is equal to rho into volume into G into L divided by A into delta L. Is it okay? Any doubts on that? Very good. So that is equal to, we can say, rho into the volume. If I want to take it in this particular movement, it will be nothing but, children, we can say area into X into G into L divided by A delta L. So this is Y. Okay. So what can we cancel off here now? A and A can be, A and A can be cancelled out. So therefore Y is equal to what now? Rho X G L divided by delta L. Okay. Any doubts on that? Very good. Here we can say, we can take delta L. So delta L is equal to what now? It is rho X G L divided by delta L. Okay. So when we are taking this particular, we can say, position here, the volume will be, we can say, children, A into dx. Why dx? Because this is the area. Okay. And this is the thickness. Are you getting it? So therefore, when you are going to take this particular, we can say, the rod. Imagine, children, this is, we can say, the rod we are taking, and this is the extra, what you can say, length. Are you getting it? Now what is the area of this? It is length into breadth. Are you getting that? So this is, we can say, area. But what about this? This will be what you can call the extra length present in that object. So that means this is not, children, x, it should be dx. Then what is x? X is this length, children. X is this length, remember that. So this is nothing but, we can say, G, and this is nothing but, we can say, dx. Is it clear to all of you? Any doubts in that? So why this is not x? Let me repeat it, children. This is not x because this is the extension produced in the rod because of self weight. Because of, we can say, the whole weight of the rod, what is the thickness extended, that is dx, and that is what we are writing here. Okay. Now this is delta x, children, but remember we need the net change in length, and the net change in length is definitely equal to integration of delta L. What is the integration now, children? What do you mean by integration? Any idea? Integration is nothing but the summation of all the variables. That is what is called as, we can say, children, integration. Remember, summation means, we can say, S, which begins with like this. Now when you take this end of S and this end of S, pull it, this is what you get. Are you getting it? So integration is nothing but summation of all the variables. This is the summation of children, we can say all the known quantities, all the constants which are having its variation in terms of integer 1, 2, 3, 4. But this is not like that. So that is what is called as integration. Let's now details of that, because if I go into details of integration, I'll require like about, we can say 1 week to complete the meaning of it only for its sign. No, that's a fact. What you're learning here is, children, we can say just a small drop of what you can call ocean. Are you going to say? Because integration is not what you know. You're just by hearting the particular, we can say, formulas and all those things. That is not integration at all. If you go for integration, integration defines the pinpoint area of a certain thing. Error defines the pinpoint mistakes that are going to make and all those things. What you are learning here is nothing at all. Are you understanding? The actual physics is totally different from what you are learning here. Anyway, let's not get off that. Wait, forget about it. Okay, forget anything I said. So delta L net is equal to what now, children? Integration of delta L. But what is delta L? What is delta L? Rho x g dx divided by, divided by y it should be, isn't it? Come on, children, let me make the changes where it is needed. Okay, so this is y. Now where does the x change from, children? X change from this position to this. What is this position now? 0, because this changes from this point to this point. Are you getting that? This point is 0. What is this point? L. Are you getting it? X is somewhere here. We don't need that x. We need this x, the complete length. It is L. Okay. So therefore, this limit will vary from 0 to L. Okay. So that is equal to what now, children? Rho will remain as it is. We can take it outside. G will remain as it is. It is taken outside. Integration of 0 to L x dx. What is integration of x dx? X square by 2, right? And if we apply the limits, it will be L square by 2. That means delta L net is equal to, children, now rho g y square, L square divided by 2y. So the right option is option 2. Verified? I may be wrong. Though of course I don't think so. Always think that I am correct. Correct, Buddha? Now let's go for the next particular topic. Mechanical properties of fluids. What do you mean by fluids? Can anyone let me know? Yeah, Buddha? Molecule? Yes. Or we can say it will be loosely packed. Not packed, it will be loosely packed. Like we can say gaseous matter, liquid, both of them are, we can say, fluids. So that means fluids are nothing but what we can say, any substance that has the property to flow. Okay, any substance that has the property of flowing is called as fluid. For example, gaseous matter is a fluid, liquid is a fluid, water is a fluid, oil is a fluid, oxygen is a fluid, carbon dioxide is a fluid. All of this has a property of flowing. So that is what is called as fluids. Okay, understood that? Sure of it? 100%. 200%, 500%, confident, lock kiya jaye. Okay. So now let's come back for we can say our physical properties of fluids. The most important one is pressure. The most important one is pressure. What is pressure, given by children? Pressure is nothing but force per unit area, F divided by A. So this is the first formula that you need to memorize. Second, of course, density, which is equal to mass divided by volume. Okay. Third one is, we can say children, Pascal's law, which says that F by A is equal to constant. That is Pascal's law. So what does this Pascal law mean? Let's understand that at the beginning first. When you go for the Pascal's law, it states that in any incompressible liquid, the pressure exerted or excess of pressure exerted at any point of the fluid will be transmitted equally over all the position of the fluid. It simply means that if we are having, let me say children, a arrangement like this, this is called as U-tube. How many of you have gone for, we can say, car washing, or maybe we can say determining of PUC in cars, in vehicles? PUC, you know, pollution, something control, right? How many of you have gone there? Have you gone? Have you seen that in those places, not of course in Bangalore I'm speaking about places such as Bangalore and all, in those places, one person will press a button, and because of that pressing in button, one particular car will go. That means any particular, we can say, the platform that contains the car will go up, and one particular small part of the platform will go down. Have you seen that? It may be in movies also, it is shown, right? I don't know in which particular movie it was. I don't know whether you have seen the movie of Surya in Tamil. There was one particular, we can say, movie of Surya and Vidyut Jamwal in Tamil, where this type of the arrangement was done. Okay, I don't know how many have seen that. Or even if you had gone for, we can say, this thing, Mission Impossible Part 7, I think, Ghost Protocol, which was filmed in India, right, in which we can Anil Kapoor was there. In that also you might have got that. Don't say it now, okay? Don't say it now, all of you, until we can see your DEET examination gets over. After that, until results, no problem, okay? Getting it? Until your counseling, no problem. Getting it? But not until then. Don't go and see, saying that Bhagya sir has given the names of the movie where we have been given, we can, the example of Pascal's law and this, that and all. And we are going to look at it. Got it? All of you. So what is the meaning of that? It means that a small force applied on a small area will result into larger force acting on a larger area. That is what is called, children, Pascal's law. That is what is called, you can say what? Pascal's law. So Pascal's law is not only, we can say, its influence in, of course, Ghost Protocol movie and all, but also in Volvo buses. In Volvo buses, I think you might have seen that the brain will be extremely smooth. Sorry, not brain, brake will be extremely smooth. The moment the person presses it, you'll not even know that it has been pressed. Isn't it? That is because of this arrangement, children. This is what is called as hydraulic brakes, depending on which law? Pascal's law. Of course, let's not get into that because we don't need, we can say, theory here, but just for the sake of understanding, we needed that. So that is why I discuss about the children. Next is, we can say, Bernoulli's theorem, which says that pressure energy plus kinetic energy per unit volume plus potential energy per unit volume is equal to constant. I think all of us might have got a experience. When you went to the railway station, there will be one yellow color line. Put, we can say, just the moment you board the platform, the train on the platform, there will be one yellow color line. Have you seen it? Do you know why that yellow color line is? To know that we should not cross that limit of yellow color line. Now the question is why? What happens if you cross that? If you cross that, at that time, if any train children is coming towards the platform and will not stop, then because of Bernoulli's theorem, you will feel like the train is pulling you towards that particular direction of its motion, and thereby we will be having, we can say, the complete, we can call the, what you can go, breaking of the particular bones of that particular person because of that. That is why the yellow color line has been kept. In some particular time, you will be feeling that if your door is closed, that time it is open sometimes, it will close sometimes by itself. It is not because of ghosts present here, we can say what, houses or something like that. It is because of Bernoulli's theorem, children. Sometimes we can feel the rattling of the windows when we can say some other particular part of the house, some windows have been closed. Again, because of the same thing. I think I should see what. Any doubts on that? Very good. So this is, we can say, children, what we can call our Bernoulli's principle. Of course, the next important one is equation of continuity, which says AV equal to constant. How many of you have, we can say, younger brothers and younger sisters? Does anybody have? Okay, one of them. 2, 3, 4, 5, 6, 7. Only 7. Nobody else. 8, 9. What about you, Buddha? No younger brother, no younger sister. Hey, Bhagwan. Elder brother. Okay. Elder brother. Do you have no elder brother, no younger sister? Thank God. Me like me only. Very good. Shabash. So anyway, whenever you go for a younger brother, younger sister, right? If you are watering the plants, right? Sometimes you will feel kind of, we can say, let me just take that water hose, just point it at that person and close, we can say, one small hole, one small part of that hole, so that the water will come with greater speed and hit that person. Ever had that type of mischief? Ever had that type of feeling? Maybe you might have done, you may not have done. Okay, ever had that type of feeling? No? Sure of it? That is because of equation of continuity. That means area decreases, velocity of the fluid increases, and vice versa. Are you understanding? That is what is called as equation of what? Continuity. Next, of course, we can, children, it is called as Torricelli's theorem. So Torricelli's theorem says that the movement of the liquid outside any closed container is having the same velocity as that of an object in the free fall. That means V is equal to root of 2gh. That is what is called as velocity of efflux, and this statement, children, is called as Torricelli's theorem. Of course, you do not know the particular meaning of it, forget about it. Okay. Next, we can say we are having relation between velocity and radius given by Vt proportional to r square. Next, you can write, children, when you are writing 8, amount of rate of liquid flow, amount of rate of liquid flow per unit time will be, take on this children, Q equal to AV, where A is the area, V is the velocity. Okay, good. Right. Now let's go for the discussion of the problems, children. So who has to read the next question?
Three liquids of equal masses are taken in three identical cubical vessels A, B, and C. Their densities are rho A, rho E, and rho C respectively. But rho A is less than rho B, less than rho C. The force exerted by the liquid on the base of cubical vessel is option 1, maximum in vessel C, option 2, minimum in vessel C, option 3, the same in all the vessels, option 4, maximum in vessel B.
Yes. What might be the answer, Buddha? So let us say we are having a container. Sorry, I think it is cubic container, isn't it? All right. Now, according to the question, what is the masses of the liquids present? Read the question again loudly.
Three liquids of equal masses are taken.
Equal masses. That means mass of liquid A is equal to mass of liquid B is equal to mass of liquid C. Correct. Now that liquids are poured in this, what we can say, container, whatever, cubical vessel, cubical container, whatever. Correct. Now what is the force exerted by the liquid on the base of the container? It is nothing but we can say the weight of the liquid given by mg. Correct. Now what is the force exerted by A? It is mag. What is the force exerted by B? It is mbg. What is the force exerted by C? It is mcg. All the particular masses are same, which means that the force exerted should also be same only. That means the right option is option 3. What is it, Buddha?
The same in all the vessels.
The same in all the vessels. Verified. I may be wrong. Correct? Very good. Buddha. Any doubt? Yeah. Equal to weight of the body, Buddha. See, picturize it like this. Leave we can say liquid. Okay, leave we can say gaseous substance. Leave we can say solid matter. Okay. Now, if any particular container is containing some particular matter inside it, the matter may be liquid, the matter may be solid, the matter may be gaseous substance. Okay. Now, what is the amount of force exerted on the floor of the container? It is the weight of that particular object itself. Like I am standing here, right? What is the force exerted by me on this part of the floor? It is my mass into acceleration due to gravity. That means even if I now take, we can say, an amount of ice equal to my mass, and if I keep it here, having the same type of the density. Okay, having same type of density means the same type of the distribution of mass, like 2 hands, 2 legs and whatever. Then the amount of, we can say, the particular force exerted on this particular floor would be again the same. Are you getting it? So when you are filling it with liquid, that definitely should be weight of the liquid, m into g. Yeah. Hamda, next question.
Water is a straight line flow along a horizontal pipe with non-uniform cross-section. At a point in a pipe where the area of cross-section is 10 centimeters square, the velocity of water is 1 meter and the pressure is 2000 pascal. The pressure at another point where the cross-sectional area is 5 centimeters square is option A 4000 pascal, option 2 2000 pascal, option 3 1000 pascal, option 4 500 pascal.
Yes, first of all try to analyze the situation. Okay, we have got a certain particular, we can say, pipe, or certain particular, we can say, connection, where we can say the whole connection is horizontal. Okay, what is the meaning of horizontal? It means that it is parallel to ground. Is it correct? Any doubts on that? What is the meaning of horizontal, children? Horizontal means the whatever the particular point is, it is parallel with ground. Now let us say this is the height h, then what will be the height here, children? H only. Correct? Any doubts on that? Very good. Now we need to connect pressure with velocity. Okay, and velocity with area. So that means there is only 2 equations, or there are only 2 equations that can make use of this. One is equation of continuity. Correct, children? Keep a pen down, all of you. We are going to solve this in the So first of all, equation of continuity. AV equal to constant. That means A1 V1 equal to A2 V2. Correct? Now what is V2, Buddha? It is equal to A1 V1 divided by A2. What is the area A1? 10 centimeter square, right? And what about A2? 5 centimeter square. So let's do one thing. Okay, since it is both in centimeter square, let us substitute directly as it is. So one is, we can say, 10 into velocity, I think it is 1 meter per second. Yeah, divided by, we can say, 5. So 10 by 5. So 10 by 5 is equal to 2. That means V2 is equal to what now? 2. Correct? Now what is Bernoulli's theorem? P plus half rho V square plus rho GH equal to constant. Correct? It means that P1 plus half rho V1 square plus rho GH, because the height is h here. Correct? Equal to P2 plus half rho V2 square plus rho GH only. So that means rho GH get cancels. So therefore P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Okay. Now we have got V1, we have got V2, we have got P1 also. What do we calculate? P2 is what we have to calculate. So P2 is equal to P1 plus half rho V1 square. Take the half rho V2 square from that side to this side. So we are going to get this as minus half rho V2 square. So half rho can be taken common. Okay, inside the bracket we are going to get V1 square minus V2 square. So this is on the other side of the plus sign. On the left side of the plus sign we are going to get P1. Okay, what is P1, Buddha? 2000, right? So 2000 plus half into rho. Now remember, density of water is always taken to be 1000 kg per meter cube. But if it is in gram per centimeter cube, it will be 1. Okay, So that means rho is equal to what now? 1000. So it is half into 1000. So half into 1000 is what? 500. Correct? 500 into, inside the bracket, 1 square minus 2 square. What is 1 square? 1. Minus 2 square is minus 4. So 1 minus 4 is how much? Minus 3. So minus 3 into 500 gives me minus 1500. Therefore, we get the final answer as 2000 minus 1500, 500 Pascal. So the right option is 4. Verified? Correct? Very good. Sure, 100%, 20%. Very good, shabash. So let's solve it now on the basis of this. Okay. See, according to question what has been asked for us put up, here he has given 2 areas. Okay. And he has given, we can say, 1 velocity. And he is asking to calculate the second velocity with which we can calculate the second pressure. Okay. So therefore, we can go for AV equal to constant. Okay, now what does this mean? It simply means that I can replace A by A1, I can replace V by V1, and I can make it equal to A2 V2 equal to A3 V3 equal to dot 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 dot. How many times you want? AN VN. Okay, but see the problem, he is asking us only 2 because he has given 2 areas. So therefore, I can take A1 V1 equal to A2 V2. Okay, so therefore what is V2 equal to Buta? A1 V1 divided by A2. So of course, both A1 and A2 are in centimeter square, so I'll substitute directly. So one is, we can say 10 into 1 divided by 5, 5 times 1, 5 times 2, that means V2 is equal to 5 meter per second. Okay, beta. So you have got, now we can say V2, we have got, now we can say V1. We have to find out, we can say P1, no, P2. Okay, so again we have to use Bernoulli's theorem. How beta? Sorry, velocity is 2. So P plus half rho V2 square, or P1 plus half rho V2 square plus rho G H1 is equal to, children, now P2 plus half rho V2 square plus rho G H2. Alright. Now remember, H1 is equal to H2 is equal to H. Right, because it is horizontal. Correct? That means rho G H1, rho G H2 cancels. So therefore we can write P1 plus half rho V1 square, children. I have to change this. Please remind me when I am writing wrong. V1 square. So it is V1 square. It is equal to P2 plus half rho V2 square. Now what is P2, children, now? P2 is equal to P1 plus half rho V1 square minus half rho V2 square. Correct? Now what is the next part of the expression? It is half rho V1 square minus V2 square. So what is P1, children? P1 is 2000 plus half will remain as it is. Remember, density of water is 1000 kg per meter cube. In the bracket, it is 1 square minus 2 square. So that is equal to 2000 plus this can be cancelled off. So this will be 500. So it is 500 in the bracket 1 minus 4, that is equal to 2000 plus 500 into minus 3, that is equal to, children, now 2000 minus 1500. Therefore P2 is equal to 500 Pascal. So the right option is Option 4. Take it down as it is.
Three equal drops of water are falling through air with a steady velocity of 10 centimeter per second. If the drops combine to form a single drop big in size, then the terminal velocity of this big drop is option 1 40 centimeter per second, option 2 10 centimeter per second, option 3 30 centimeter per second, option 4 80 centimeter per second.
Yes. So, what might be the answer? How to calculate it? To do that, help me out. Okay. Let us say n drops are present. Let's not say only 8 drops. It may be 10, 20, 100, 1000, anything. Okay. So, let us say that n drops are present. These n drops are falling individually. When they reach some part of the atmosphere, they combine to form bigger drop. Let us say that the radius of individual drop here is r, small r, and the radius of the bigger drop, which is formed by the combination of this, is capital R. Okay, Buddha? Now remember one factor here, that whenever we can say these drops are combining together, the radius of the bigger drop is not equal to n times the radius of the smaller drop. That will never happen, Buddha. Are you understanding? So, here what we can see is that the volume of the bigger drop will be definitely equal to the volume of this complete drops. That means VB, what is VB? Volume of the bigger drop is equal to n times volume of the smaller drop. Are you getting what I am saying, Buddha? Any doubts in this? Very good. So, volume of the bigger drop is equal to n times volume of the smaller drop. Now, we take that the ideal shape of a liquid drop is sphere. That means what is the volume of sphere? 4 by 3 pi r cube. Correct, Buddha? So, therefore, I can write here 4 by 3 pi capital R cube. Why capital R cube? Because volume, VB is volume of the bigger drop and radius of the bigger drop is R. So, here that is equal to n times 4 by 3 pi R cube. Can we cancel anything off, Buddha, here? 4 by 3, 4 by 3, pi. That means R cube is equal to n times R cube. Or we can say R is equal to n to the power 1 by 3 small r. Is this part understood, Buddha? Now, why did I take the radius? Because in this formula we can see velocity is proportional to square of radius. Correct, Buddha? So therefore, I need to find out what is velocity. Therefore, I find out what is radius. Okay, Buddha? Now, what is velocity proportional to? Velocity is proportional to r square. Okay. Now, what is velocity of the smaller drop proportional to Buddha? The velocity of the smaller drop is proportional to small r square. And velocity of the bigger drop is proportional to capital R square. Okay. Is it clear to all of you? Very good. Now, velocity of the bigger drop divided by velocity of the smaller drop is equal to r square divided by r square. What is r? N to the power 1 by 3 small r. So then I can write this as n to the power 1 by 3 small r square divided by r square, children. That is equal to n to the power 2 by 3 r square divided by r square. Can I cancel something off here? R square may cancel off. Therefore, velocity of the bigger drop divided by velocity of the smaller drop equal to n to the power 1 by 3. Very good. 2 by 3. So that means velocity of the bigger drop is equal to n to the power 2 by 3 into velocity of the smaller drop. The number is given as 8, correct? So this is equal to, we can say 8 to the power 2 by 3 into velocity of the smaller drop is given as 10 meter per second, correct? Velocity of smaller drop, see there in the question, 10 meter per second, isn't it? So what is 8 to the power 2 by 3? Cube root of 8 is 2, 2 square is 4, 4 into 10 is 40. The answer should be 40 centimeter. Okay, centimeter per second. The right option is option 1. Verify, children. I may be. Okay, good. I know. Thank you, children. Yes. What might be the answer, Buddha? So let us first of all try to understand what is the meaning of capillary rise. Okay. So capillary is nothing but we can say a small fiber like we can say glass tube. It will be extremely thin. Okay. That is what is called as capillary. Normally you might have seen capillary in your first year, what you can call laboratory. There we are going to get one glass rod, and inside the glass rod we are having a small particular we can say glass fiber like structure. So this is called as capillary. Now what is the meaning of capillary rise? Let us say that we take this rod and we put this in a container containing liquid. Now when you are going to go for liquids, there are generally three types of liquids in consideration. The first is we can say the liquid which will be present in this manner. Here this particular we can say what liquid has got a certain particular we can say property of wetting the container it is put into. For example, water. Okay, when you take water and when you take any vessel and you clean the vessel with the vessel contains water droplets in it. Correct? And that is what is called as wetting. What you can call container is wet with water. Are you getting that? So this will be possible for only those liquids which are having one particular angle which we call angle of contact as acute. That means the angle should lie between 0 degree and 90 degree. Now what is the meaning of angle of contact? So angle of contact is nothing but the angle made by the tangent drawn. Angle made by what, Buddha? Tangent drawn at the point of contact of liquid and solid. At the point of contact of liquid and solid. That means this is the tangent with the solid itself. Okay. So this is called theta. So here this theta is less than 90 degree. So this liquid wets the surface of the solid. Okay. Now let us say I go for another part of the liquid like this. Now where is the point of contact of solid and the liquid? It is here. Right? Now what is this angle now? This angle is theta, but this theta is greater than 90 degree and of course less than 180 degree. So this type of the surfaces do not wet the surface. Okay. So now if I take this type of the liquid here, then remember inside the capillary the liquid will be rising at the top of the liquid in the container. That means the height of the liquid is greater than the height of the liquid in the container when I take this liquid. But by chance, if I take this type of the liquid, then the liquid height inside the capillary will be lesser than that in the container. That means in the first case, liquid rises. In the second case, liquid falls down. Are you getting that? But in both the cases, we call capillary rise only. In both the cases, capillary rise. It may be falling, it may be rising. Both means capillary rise. The height of this fall and rise is given by h equal to 2t cos theta divided by r rho g. Okay, beta. This is what you have to remember. Another formula for your memorization. Okay. So now he is telling us that the variation is only because of the what? Radius and height, isn't it? That means here we can see that height is inversely proportional to radius. That means more the radius, less the capillary rise, less the radius, more the capillary rise. So that means the right option is put up. Option 3. Verified. I may be wrong. Correct? Very good. Shabash. Okay, fifth one we can refer it yourself, put up. Here we can see it's greater than 1, you can go for option 4. Okay, go for the next question, that is sixth question.
Solids P and Q float in water. It is observed that P floats with half of its volume immersed and Q floats with two-thirds of its volume is immersed. The relation of densities of P and Q is option number 1 4 by 3, option number 2 3 by 4, option number 3 2 by 3, option number 4 3 by 2.
Yes, what was the answer, Buddha? Let's find it out. Okay, see, according to the question, there are two solids, correct? One is solid P, another is solid Q. So let me say, I take solid P first. Okay, now when I take the solid P and I take the container containing liquid, and the liquid is water, isn't it? Right? So when you take the container containing water, the solid is such that 50% of the solid is immersed inside the liquid and 50% or the rest 50% is outside the liquid. Is it correct, Buddha? Very good. Now when you are going to go for the forces that is acting on this solid, there are two forces. One, the weight of that object, and the weight of the object is given by Wp. Agreed, Buddha? Very good. And the second is, we can say, the force of upthrust given to this object. And the force of upthrust is such that 50% of the body can only go inside. The remaining 50% should remain outside. Okay. Now we can say that means the buoyancy force on P. Now what is this weight on P, Buddha? The weight on P is nothing but mass of P into acceleration due to gravity. And the upthrust is given by volume of the solid present inside the liquid, I will call it as VLP, into density of the liquid, that is nothing but we can say rho W, into of course we can say G. Can we cancel anything off, Buddha, here? G can be cancelled off. Now what is this MP? Mass of the solid. It is density of solid into volume of solid, which is equal to, okay, instead of writing it as Vs, I will write it as Vp, volume of solid P. Okay, that is equal to, what is volume of the solid present inside the liquid, Buddha? 50%, that means 1 by 2, half of it, correct? 1 by 2, isn't it? Half of it is immersed. That means it is Vp divided by 2. And rho W remain as rho W only. What can I cancel off, Buddha, here? Vp can be cancelled off. That means rho P is equal to what now? Rho W divided by 2. Call this equation number 1. So this is for what? Solid P. Now let's go for, we can say, solid Q. in solid Q. We take again water. And how many part of the solid Q is immersed inside water? 2/3. That means this is 2/3 and this will be 1/3. Correct? Now we are going to go for the same thing. That is, the weight of the solid is balanced by the buoyant force. That means MQ into G is equal to amount of solid Q inside the liquid. That is volume of the solid Q inside the liquid into density of liquid into G. Alright. Can we cancel anything off, Buddha? G can be cancelled off. Then what is MQ? Again the same thing. Density of Q into volume of Q is equal to, this volume is 2 times volume of Q divided by 3 because 2/3 is immersed into, we can say, rho W. So can we cancel anything off? Volume of Q can be cancelled off. Then what is rho Q, Buddha? Rho Q is equal to 2 rho W divided by 3. Call this as equation number 2. Okay. Now, let's come back for rho P divided by rho Q. That is equal to rho W divided by 2 whole divided by 2 rho W divided by 3. What can we cancel off? Rho W can be cancelled off. That means rho P by rho Q is equal to 3/4. So the right option is, yeah, second one. Verify it. I may be wrong. Okay, just you can try the 7th question here, children. It is, we can say, Reynolds number question, I think. So this is, we can say, actually out of syllabus. So it's not going to come for your syllabus now. But if you want, we can say it's a theory question also. So leave it. Go for the 8th question, Buddha. You only, Buddha. You only, right? Yes. What was the answer, Buddha? So, instead of going for what is the option, which formula can we apply here? So, as it is, we can say area is given to us. We have to find out velocity. So, formula is A V equal to constant. Correct? That means AA VA equal to AB VB, where A is the area of A, VA is the velocity of any liquid in A, AB is the velocity of, area of B, VB is the velocity of liquid in B. Okay, Buddha? Any doubts on that? Very good. Now, what is asking us to calculate? He is asking us to calculate the ratio. The ratio of what to what? Louder. Velocity of A to B or B to A? A to B. That means VA by VB is what he is asking us. Correct? What is VA by VB? It is equal to AB by AA. What is AB, Buddha? Remember, he has not given area directly. He has given that in terms of radius. Correct? So that is, we can say pi RB square. divided by pi RA square. Pi get cancels. RB square divided by RA square. What is RB square, beta? That is radius of B. Radius of B is 5 centimeter. We have to find out diameter. Diameter is 5 centimeter or what? Diameter of that is, we can say 10 beta. Second one, VB, right? We have to consider RB. So VA by VB is equal to AB by AA beta. AB is nothing but pi RB square divided by pi RA square. Pi get cancels. Okay, so it is RB square divided by RA square. So forget about, we can say, the radius and diameter, directly substitute, because remember it is a ratio. It is what? Ratio. That means you take it as a diameter, you take it as a radius, both will remain one and the same. That means the ratio will be cancelling off the constant. Getting it? So we can say RB square or DB square, whatever the case is. RB is the radius, DB is the diameter. It can be taken as 10 square. What is 10 square, Buddha? 100 divided by RA square or DA square, whatever the case is. Take it as 5 only. So 5 square is 25. So it is 100 by 25. 4:1. The right option is option 1. Verified. I may be wrong. Correct. Very good. Yes. So let's find it out. Okay. So read the question again loudly, Buddha. So this is what we have to find out. Now remember, AV equal to constant, which means that AA VA equal to AB VB. Correct? Now AA is nothing but pi RA square into VA equal to pi RB square into VB. So what can I cancel off here? Pi can be cancelled off. Okay. As you can see, we need diameter here. So what we can do, directly multiply on both sides by 4. Okay. I can multiply here by 4 and here also by 4. So as we can see here, since 4 is to be multiplied on both the sides, here we can substitute radius in terms of diameter, or directly we can substitute that value itself. Not an issue. Okay, beta? Because 4 and 4 get cancels. Getting it? What is diameter? It is 2 times radius. Correct. But here we need 2 times square. 2 times square is 2 square. 2 square is 4. That is what you are writing here. Are you writing that? But 4 should be multiplied on both the sides. And definitely we are going to cancel that. We don't need it. So therefore, even if I take DA or RA, we can substitute this as this value only. Are you getting that? Because this is CD beta. Here we did not go for, we can say, the method. Here we need the answer. Getting it? If it is boards, then definitely you should go for these all things. Because in boards, you are not supposed to make shortcut for any numerical. Getting it? But since this is not boards, I can directly take this as 5 and 10 only. But still, let us do one thing. Let us take this as 2RA the whole square into VA equal to 2RB the whole square into VB. So this is the we can say dA square VA equal to dB square into VB. But what do we need, Puta? We need VA divided by VB. That is equal to dB square divided by dA square. So what is dB? 10 square divided by 5 square. But remember again that we have to get the variation on centimeter. So therefore, I can directly substitute that because that cancels off. Because numerator also will be getting centimeter square, denominator also will be getting centimeter square. So this is equal to, we can say 10 by 5 the whole square. So 10 by 5 the whole square is 2 square. That means VA by VB is equal to 4, or the ratio is 4:1. So the right option is, take it down. Okay children, so you can leave 9 and 10 question off. Go for the 11th question. Just theory question, you can solve it yourself.
The cylindrical container containing water has a small hole at height of edge is equal to 8 centimeter from the bottom and at a depth of 2 centimeter from the top surface of the liquid. The maximum horizontal distance traveled by the water before it hits the ground, x, is first 4 centimeter, second 8 centimeter, third 6 centimeter, fourth root 2 centimeter.
Yes. So, what is the meaning of maximum horizontal distance? What is the name given to that? No, Buddha. Trajectory is the path followed. Yeah, trajectory of a plane, projectile is a parabola. Okay, but what is the maximum horizontal distance? It is called as range. Okay, what is called as, put up? Range. Very good. So range is equal to velocity into time. It requires to reach there. Now pay attention here very carefully and let me solve it. So this is, we can say, the top of the liquid. Correct? Now according to the question, children, a small hole is present at a depth of 2 centimeter from the top of the liquid. Correct? Isn't it? Yeah, Buddha. Is it correct? Depth 2 centimeter from the top of the liquid. But from the bottom of the container, it is 8 centimeter. Is it correct? Very good. Now let me call this as capital H. Let me call this as small h and this as d, because this is the height, this will be the depth. Okay. Now remember, velocity is equal to root of 2gh. but here the h is, we can say, d, that is the depth. So that is given by root of 2 into 10 into 2, that is equal to root of 40, whatever the unit may be, it's not important. Okay. Now we need to find out the time put out. Now remember, the time required by the particular body to reach the maximum distance from here. Correct? Now when we can say we take the velocity at the beginning, the velocity is 0. The distance, we can take it to be h, and the time we are going to take it as, we don't know, of course, question mark, and we are having acceleration equal to acceleration of gravity g. How to connect all of these 4 quantities now? Yeah, but here this v is the speed at that position, Buddha, but we don't need v because it is the velocity at which the particle reach here from this to this. So that time, this velocity we did not consider because this time is different. The time at which this reaches at that velocity is different. So we need to have the time such that the whole part of this will be gone. So that means I need to connect u with s, with t and a. S is equal to ut plus half ad square. Very good, children. Shabash. This implies h is equal to, this is 0. Then this is half g t square, or this implies, I'll write directly, t is equal to 2h divided by g. Now what is t beta? That is equal to root of 2 into, what is h? 8 divided by 10. That means t is equal to, can I write this as root of 1.6? Okay. Now I need to find out r. What is r? It is equal to v into t. What is v, children, now? Root 40 into root of 1.6, that is equal to root of 40 into 1.6, that is equal to, can I write as 64? Therefore r is equal to 8 centimeter. So the right option is option 1, or of course second. Okay, so the right option is option 2. Verified, I may be wrong. It's correct? Very good. Huh? What you are doing, children? Huh? Okay. Next, Yarapa.
An aluminum sphere is hanged into water. Which of the following is true? Option A. Buoyancy in water at 0 degrees Celsius will be same as that in water at 4 degrees Celsius. Option 2. Buoyancy will be less in water at 0 degrees Celsius than that in water at 4 degrees Celsius. Option number 3. Buoyancy may be more or less in water at 4 degrees Celsius depending on the radius of the sphere. Option 4. Buoyancy will be more in water at 0 degrees Celsius than that in water at 4 degrees Celsius.
Okay, so you can say option 2 is the right option there. Go for the next question, Buddha. हाँ नंबर है मत यार Right. So, just pay attention now. Let us say this is liquid water, and in liquid water we are having ice. As we already discussed, when you go for this type of the arrangement, we can say that the weight of the solid is balanced by the buoyancy force or the upthrust. Okay. Now, what is the weight of ice? It is mass of ice into acceleration due to gravity. That is equal to, we can say, density of water into volume of ice inside water. Remember children, it is volume of ice inside water into, of course, G. Now what can I cancel off here? G can be cancelled off. Now what is mass given by children? Mass is given by density of ice into entire volume of ice, which is equal to density of water into volume of ice inside water. Now remember, he is asking us about fraction of the ice. Now fraction of ice means we can say amount of ice, that is volume of ice in water divided by total volume of ice. That means volume of ICE. That is equal to, when I go for this, we can say that this is nothing but density of ice divided by density of water. What is density of ice? 0.917. Is it in terms of gram per centimeter cube or kg per meter cube? Gram per centimeter cube. Then remember that if it is in gram per centimeter cube, you need to substitute the volume of, density of water as 1. If it is kg per meter cube, you have to substitute it as 1000. Are you getting it, children? If it is gram per centimeter cube, it is 1 gram per centimeter cube. If it is in kg per meter cube, 1000. So this is equal to, we can say 0.917 divided by 1. That means the fraction of ice immersed in water is 0.917 itself. So the right option is third option. Verify it. I may be wrong. Okay, children, I will be leaving the 14th question for you. Okay, 14th question is, we can say we have been given height of capillary rise, and he is asking us to calculate the ratio of diameters. So formula is simple. H is equal to 2t cos theta by r rho g. R we have to multiply by 2 and divide by 2. We will be getting that in terms of diameter, and then we can go for the remaining. Yes. So try that. If you don't get it, I will solve it. Okay. Go for the 15th question now, children. And make it fast, because we will solve this in 2 minutes.
Closed water tank has cross-sectional area A. It has a small hole of H on free surface of water. The radius of the hole is r, so that r is much lesser than root of A by time. If P0 is the pressure inside the tank above water level and PA is the atmospheric pressure, the rate of flow of water coming out of the hole is rho is the density of water. First option, pi r square root 2g h. Second option, pi r square root g h plus 2 into rho naught minus p naught minus p a by rho. Third option, pi r square root 2g h. Fourth option, pi r square root 2g h plus 2 into p naught minus p a by rho.
Yes. So let us try to understand the question first, Puta. So according to the question, we have been given one container of liquid, right, and we have been given some particular height from that particular top of the liquid. It is, I think, capital H or small h? Small h. Okay. Okay. And he is telling us that we have to calculate the rate of flow of fluid. The rate of flow of fluid is given by, remember, A into V. Okay. What is A beta? A is area given by pi r square that we have got. But now we need to find out what is the velocity. To find out the velocity, we are going to make use of Bernoulli's theorem. What does that say, beta? It says that P plus half rho V square plus rho G H is equal to constant. Correct? Now see, for the top of the liquid, that means the free surface, at the free surface, velocity is 0. Because normally we can say the free surface, the velocity will be constant or 0 in the closed container. That means there we can write pressure at the free surface, that is given by P naught. Correct, beta? Huh. Plus velocity is 0, forget about that, rho G H. Yes, that is equal to. Now we should go for the atmosphere. That means the liquid is coming out. In that condition, we are having P as PA, that is atmospheric pressure, right, plus half rho V square, where V is the velocity. Now, from this we can write half rho V square equal to P naught minus PA plus rho G H. So we'll take 2 to the other side, and therefore we are getting rho V square is equal to 2 times P naught minus PA plus 2 rho GH. Now V square is equal to 2 P naught minus PA plus 2 rho GH whole divided by rho. Pi r square is the radius, beta. So area that we are going to substitute in this A. Okay. All right. Any doubts until this?
There P R A plus half rho V square
हाँ बेटा.
plus rho G
H is 0 because this is at the bottom of the container. So that will be 0. So that means now we are going to get V square is equal to 2 P naught minus PA divided by rho plus 2 rho G H divided by rho. Can we cancel something off? Rho can be cancelled off. That means V is equal to what now, children? Root of 2 P naught minus PA whole divided by rho plus 2G H. Now let us substitute this Q. So Q is equal to pi r square into root of this. So the right option is option 4. Verified? I may be wrong. So let's stop here, children, and meet in the next class. Thank you.